Aloha and welcome to our video on understanding air pressure. In this video we'll describe how air pressure exerted on objects, we'll explain how changes in air pressure affect the mercury column of a barometer, and finally we'll identify factors that affect wind. Okay, so earlier in another video we talked a little bit about air pressure and we kind of saw a drawing that looked a little bit like this one over here. What I wanted to show you is you can see how, remember, most of the air is down at the lower part of the atmosphere, so we can see an awful lot more of the air molecules there than we see up here. Because there's more down here, we're going to have more pressure, obviously. Here we have lower because there's less of that column that's still weighing upon them. If we look here, we'll look at somebody at sea level here, and our individual at sea level is being pushed on by this entire column of air that's pushing down, but it's pushing in all directions upon him. So you can see how he's experiencing more pressure than our individual here at the top of the mountain who has only this small little column of air pushing down, and there's less molecules adding that pressure to him. So we do notice a difference in pressure from sea level as we travel up through the atmosphere. And it's going to be more pronounced initially in the lower level, lower altitudes, because we have this higher amount down here. So we'll see a larger variation quickly as opposed to when we get up higher here where we get a smaller variation change. Okay, so how do we measure air pressure? We use a tool called a barometer. And on this page we can see two different kinds. The first one is a mercury barometer. And under high pressure, we're going to have a lot of pressure coming down. It's going to force this mercury in the pool here to go down, so its only escape will be to go up the tube here, and we can measure our high pressure here. If we have low pressure, there's going to be less forcing here, which is going to cause the mercury in the tube to come out and fill in the pond. We'll see the pond level rise a little bit, and then we'll get a lower pressure value there. So a mercury barometer gives us an instantaneous what's our pressure there. The aneroid barometer that we see here, because it has a rotating cylinder, this is going to be turning, and as it does so, it'll record what the changes are in pressure over time. So we can kind of get a picture that way. The way that this one works is we have this chamber of air, and as it's increase in pressure, this chamber gets smaller. As it gets smaller through a series of pulleys and levers, it'll cause the pen here to rise up for high pressure and then to drop back down for low pressure. So one of the interesting things, and we'll learn about pressure here a little bit further as we're talking about different types of air masses, but we'll see that we have our weather maps, and on our weather maps we have these lines which we call isobars. Remember, iso is same, and then bar would refer to a millibar, how we measure pressure. So each of these lines are going to be pressure lines, so we can see what the air pressure is and where it is. So here we have a high pressure system here, where we can see represented by this H, and we'll have a low pressure system right in through here as well. And we'll talk more about these pressure systems and how they affect our weather in the next couple of slides and videos. Now, in a future video, we're going to talk about how winds are formed. And basically what we need to know is that we have areas of high pressure, which means we have a lot of air here. So high pressure has a lot of air. And then we have our areas of low pressure, where we have a little bit less air in those areas. And what we're going to notice is that the air from a high pressure is going to want to move to a low pressure. And that's how we make wind. And we'll cover this a little bit more detail in our next videos. One of the things, if you remember back to currents, we talked about was this Coriolis effect. And we talked about how the Earth is spinning. And because the Earth spins in this direction, if we have a movement of something not attached, like current was water not attached to the surface, or wind, which is the atmosphere which isn't attached to it, then we have this bending effect going on, which we call the Coriolis effect. So in the northern hemisphere, if you can recall, it's going to travel and bend a little bit to the right, caused by the rotation of the Earth. So we can see if we had a wind that was blowing from the North Pole to the equator, it would bend a little bit to the right, and we'd see that aspect change there. And it's just the opposite if we go down to the southern hemisphere, where it will bend to the left. And we can see if we had a wind blowing up from the south, it would do that. So this is how we get a change in the winds, and we'll talk more about this a little bit later on. I just wanted to remind you of the Coriolis effect. So that's it for our video. As always, good luck on the quiz, and we'll see you in the next video.